Hello, welcome back. So in this video, we compare two population means using t-student test for paired samples. And to be more precise, we are to discuss two-tailed test. So we have a group consisting of 9 patients, and the data are self-assessment of their mental health. So subjective evaluation of their mental health provided by the patients before and after the therapy. And our task is to assess whether people attending therapy report a different level of subjective well-being before and after the therapy. And we assume that alpha is equal to 0.1. At this point, I hope it is very easy for you to figure out that we indeed perform two-tailed test due to the way our research task is formulated. So we are not interested whether their state after the therapy is better or worse than before. For us, it's enough to know whether it is different. So keep in mind we have 8 degrees of freedom because there are 9 pairs of observations in our sample. And because we perform two-tailed test, we have to analyze both sides of the distribution, and that's why we will have to split alpha by half. So alpha should be equal to 0.05. We have 8 degrees of freedom, so the critical value is 1.86. We design the rejection regions. So because we perform two-tailed test, rejection region, the first one, is everything to the right from 1.86 and everything to the left from negative 1.86. Now we are going to compute the test statistic. And actually it's useful to do this in several ways. If you can do this in Excel, it's even better. So first of all, we calculate the difference between self-assessment scores before and after. In this case, I subtract after from before because it makes no difference for two-tailed test. So those are our differences. We have to calculate the average value out of those, and it is equal to negative 1.2. We calculate standard deviation of differences. Actually, I used the Excel function for this, but please remember that when you calculate standard deviation for sample, you have to choose the function for calculating standard deviation for sample. The difference is not going to be that significant, but just for the sake of precision, let it be. And finally, we have mean difference, xd bar. We have standard deviation of differences, sd. We have 9 observations, so square root of nd is equal to 3. And keeping this information in mind, we calculate the statistic, just based on this formula. So it's equal to negative 483 approximately. And yes, when we analyze the rejection regions, we can definitely say that it goes within the rejection region. In other words, we can safely reject the null hypothesis in favor for the alternative hypothesis and conclude that self-assessed state of mental health of patients before and after the therapy is indeed different. We can also go for p-value. So here we are going to look for the closest value corresponding to our number of degrees of freedom. So we have 8 degrees of freedom. The statistic is negative 483. And here it is. So here, this is the value of t for alpha equal to 0.01. But because we perform two-tailed test, you will have to multiply it by 2. So in fact, our alpha is equal to 0.002, which is smaller than 0.01. So we should reject the null hypothesis for alpha equal to 0.1, and we can also conclude that this hypothesis can be rejected at the 1% significance level. So again, when you just add the hypothesis, you are provided with the value of alpha. I just wanted to demonstrate that if you assume a much smaller value of alpha, the hypothesis is still rejectable, still subject to rejection. Okay, you've got what I mean. Okay, so that was it. In the next video, we are going to discuss one-tailed test for pair differences. So thank you for watching.